Okay, in this lesson we'll talk about geometric sequences, and a geometric sequence progresses by multiplying by the same number every time, and that's called the common ratio. And we have an explicit formula for this. Let's see how that is generated. If we look at this, we have the sequence, just like we normally put the sequence into a table. Instead of saying that we're going to multiply by a half from each previous term, let's look at what has happened so far in each term. So for the second term, we have multiplied by a half to get to the second term. We multiplied by a half. To get to the third term, we have multiplied by a half twice. To get to the fourth term, we've multiplied by a half 3 times. And to get to the fifth term, we've multiplied by a half 4 times. And if we write it like this, we can see that this creates an exponential expression. Also look at, for the second term, we have an exponent of 1. For the third term, we have an exponent of 2. Fourth term has an exponent of 3. And that's where the formula for the nth term comes up. We just copy this is called the common ratio. There's the first term, and then we have n minus 1 as the exponent. So let's put it into a table. And to find the common ratio, we would divide negative 2 by 8. Negative 2 divided by 8, and we get negative 1/4. Here we have 1/2 divided by negative 2. We also get negative 1/4. So this is called the common ratio. Then we can use it, negative 1/4, to get to the next 3 terms. We find the common ratio by dividing, but then when we use it, we're going to be multiplying. So 8 times negative 1/4 is negative 2. Negative 2 times negative 1/4 is positive 1/2. And now we're going to continue multiplying. 1/2 times negative 1/4, negative 1/8, times negative 1/4 again, that'll be a positive 1/32, times negative 1/4 again, we get negative 1/128. Alright, then it talked about analytic forms, and analytic also could be called algebraic. So we can look at the recursive formula, and we just write down what the first term is, and then how to get to the next term, which is negative 1/4 an minus 1, where n has to be greater than or equal to 2. The explicit formula is an, and that's what we're doing. We're using this formula. First term times the common ratio, negative 1/4, to the n minus 1. That is a correct answer, but sometimes, maybe on a multiple choice test, you'll have to write it like this. So when we have an exponent, we can split this up, this base, into the base to the power of n times the base to the power of -1, and that's just an exponent rule. We can break it up like this. So now we have 8. This -1 means reciprocal, so that'll be times -4. This is negative, the reciprocal of this is -4, and then just copy that. And we have -32, -1/4 to the nth. And then you want to make sure you check it. So if we put a 1 right here, then we'd have -32 times -1/4 is +8. If we put a 2 right here, that would be positive 1/16. 1/16, so that's -32 divided by 16 is -2, and that will be the explicit formula. Four, 11, 30.25. That's not a comma, that's a decimal. So, same question. You're going to find the next 3 terms and then find the analytic forms. Pause the video and try that one. So we're looking for a common ratio, and that would be by dividing 11 by 4, and we get 2.75. Here we're going to have 30.25 divided by 11, which is 2.75. So we know that that's the common ratio. We can find the next 3 terms if we multiply by 2.75. So if we did that, the 4th term would be 83.1875. Multiply again, and we'd have 228. I'll just round it, 0.77, and 629.11. These are rounded, so if you multiply this by 2.75, you won't get that. But if you never round it and you just round each of them, that's how they would round. Okay, recursive, write down the first term, and then write down how to get to the next term. 2.75 times the previous term. And the explicit formula is a1r to the n minus 1. So that's going to be 4 r to the n minus 1. And we could continue, we could rewrite that to get rid of that minus 1 there, but for now just leave it the way it is. Alright, and we could have some variables, so analyze this the same way. Pause the video. And we want to look for what is 2w plus 6 divided by w plus 3, and that equals 2. We can see that we're multiplying this by 2 to get there, times 2 times 2, so we know that 2 is the common ratio, and we could find the remaining terms. Times 2 recursive formula is the first term. Oops, not like that. We're going to write it like this. an equals 2 times the previous term. And we're getting that from the common ratio of 2. So to get to the next term, we just multiply the previous term by 2. Explicit form is just the first term times the common ratio to n minus 1, to the n minus 1 power. Alright, find the 9th term. So let's find the nth term, or the explicit formula. Then we just have to substitute a 9. We want to find the common ratio, 14 over 4, 7 over 2. Here we have 49 over 14, which is also 7 over 2. So we know the common ratio is 7 over 2. And then we can find the nth term, or explicit form, and that is the first term times the common ratio to the n minus 1, and that's coming from a1r to the n minus 1. It asks for the 9th term, so now we just substitute a 9. 9 minus 1. And get that. Okay, this one doesn't give you the first term, but you could pretty easily find the first term and then repeat what we did in the previous problem. So pause the video and try that one, and then we'll go over an additional strategy for this. Okay, the third term is 32, and we know that we are multiplying by 4 to get to the next term because they gave us the common ratio, -4. So we could just divide by -4 and work backwards, and that would give us a -8 if we divided by -4. Divide by -4 again, we have 2. To check, we'd want to make sure that when we multiply by -4, we're going from 2 to -8 times -4. So that's the correct, those are the correct terms. We need to find the 12th term. So based on what we did here, we would have a(n) equals a1r to the n minus 1. a1 is 2, r is -4 to the n minus 1. To find the 12th term, we just do this, and we have that number. Here's another strategy. What if you were already starting at like the 12th term and you didn't want to go back that far? Well, another strategy would be this. Let's just make a new index. Instead of starting 1 right here, let's call this the first term. And then if we were going down this way to the 12th term, well, now this would be going to the 10th term. So we could just start with this as the first term of a sequence that goes to 10. So the 12th term in this sequence is the same as the 10th term if we are starting at 32. So we could do it this way, or we can have a(n) equals the first term, the new first term, times -4 to the n minus 1, and then we would have a10. And we'll get the same answer. All right. Let's always start a problem out like this. And the 4th term is -4, and the 7th term is 13.5. If we, and here we don't see what the common ratio is, but what if we just said this is going to be the first term of a new sequence, and then we can use the nth term formula. So instead of having to, here we can't find the first term because we don't know what the common ratio is, but why don't we just say this will be the first term of a new sequence, that'll be the fourth term, and then we can solve for the common ratio. So here we'll have 13.5. A1 will be -4. We're going to solve for the common ratio, and n is going to be 4. All right, it's easier to deal with fractions, so let's call that 27 over 2 is 13.5. Because now we can divide by -4, and then we can just have this be 27 over 8. We will do the cube root of both sides, and the cube root of 27 is 3, the cube root of 8 is 2, the cube root of a negative is a negative. So now we know the common ratio, and it wants the geometric means. The geometric means are just going to be the terms between the other whatever terms you have here. So here's a term, a geometric mean, the next geometric mean is here and then there. So here we're going to have, if we multiply by -3 over 2, then that will give us +6. Multiply again, and we'll get -9. All right, same question. And again, instead of saying geometric means, they could have said terms of the sequence. All right, analyze that the same way. Pause the video. We don't know the common ratio, so we can call this the first term, and that'll be the fifth term. That allows us to use this formula where the fifth term is 0.016, the first term is 10, common ratio we're going to solve for, and n is 5, because if we're starting at 10, now this is the fifth term instead of the seventh term. So I'll put a 5 up here. And I won't bother with a fraction here. Just divide by 10. That'll add another decimal place. We'll do the fourth root. And we get 0.2 is the common ratio. Then we can find the next term, the terms between these two terms. So 0.2 times 10. Then we're going to multiply by 0.2. multiply by 0.2, and then multiply by 0.2, it would take us right there. And that's the end of this lesson.